I want to talk to you today about touch and input in Jetpack Compose. My name is Jolanda Verhoef. I'm a developer relations engineer working at Google with Compose for the past years. And I want to talk about kind of gesture handling and everything with you today. I want to take you on a journey. That's the plan. Showing you how to create beautiful and rich interactions for your Compose apps. And after today, I want you to be able to reason about and easily implement custom interactions. So what do I mean with that? Let me show you some examples, because that's the best way to show you, right? So you might want to select content by dragging your finger over the screen. I'll be showing this like 20 times more. Don't worry about pictures. There will be a lot of picture opportunities, a lot of like short links and stuff, but go for it. Or for example, what about letting a user zoom in and pan images? It's a common thing that you might want to implement, but it's not super trivial, so I'll be guiding you through that. And let's say that you made this nice custom graph, and you would like to highlight parts of this graph when the user drags over it. Or maybe a messaging app, and you want the user to be able to record a message, but then when they swipe to the left, you want to cancel that recording. So all of these are examples of where touch and input and custom gesture handling comes into play. But if we want to talk about these rich interactions, we do need to make sure that we have some common terminology, because then we're talking about the same things, right? So first, Android nowadays isn't just phones with touch interaction anymore. So to be inclusive with other form factors and input types, we do have to come up with kind of a more general term than touch. So in Compose, we use the term pointer to refer to any type of input that is used to point at things on your screen. And then with a pointer, a user can perform a gesture. So using the phone with touch concept here, a gesture would consist of a user putting their finger on the screen, optionally maybe moving it around a little bit, and then letting go again. And that whole thing is then a gesture. So on a low level in Compose, such a gesture is represented by a stream of pointer events. So for our gesture, we would first see a press event, then we'd see a bunch of move events, and then finally a release event when the user lifts their finger again. In total, the sum of all of those events between pointer down and pointer up is what we call a gesture. Of course, the user can also use more than one finger to perform a gesture. So in this case, the two pointers, so the two fingers, are performing a pinch gesture by moving outwards and then inwards again. Probably the user will not put their fingers down at exactly the same time. So what you would see is you would first get this kind of first pointer down and then some move events for that finger. And then the second one goes down, both of them are moving at the same time, and finally both of them release. Now, to recognize such a thing as a pinch to zoom gesture is not super trivial, right? There's a lot of like low-level events hanging. So this is why Compose includes several helper methods for us. So instead of having to do all that kind of low-level analysis, we can just say, I want pinch to zoom support. And this brings us to our toolbox. So what helpers can we use to implement these gesture handling in our app? There's four kind of levels of abstraction. So on the lowest level, what we were just looking at, we can use and interpret pointer events directly. This is done using the pointer input modifier. And it gives you the most flexibility to implement exactly that gesture that you want. But for some common gestures, such as dragging, tapping, zooming, and panning, the pointer input modifier actually contains a set of gesture recognizers. These recognizers translate raw pointer events to full gestures. Now, one level up, gesture modifiers, such as clickable and draggable, allow you to add gesture handling to arbitrary composables. So you can just use that modifier directly. You do not have to use a pointer input modifier. They also contain some extra functionality, and we'll handle that a little bit later in the presentation. And then finally, some of our components, such as a button or a slider, they actually include gesture recognition right out of the box. So for this talk, I'll be focusing mostly on those middle two layers, because that's the ones that you will actually be using the most when you're building with Compose. So we'll talk about gesture recognizers and gesture modifiers. Let's start with the gesture recognizers. To create one, you first apply the pointer input modifier to your composable, and you pass a lambda to this modifier. Inside this lambda, you're in a so-called pointer input scope. And this scope gives you like a bunch of those recognizers to work with. So within that pointer input scope, for example, you can use the detect tap gestures method to recognize various tap gestures: double tap, long press, press, and tap. You pass the lambdas for the tap gestures that you want to respond to, and then those lambdas will be executed whenever that gesture is recognized. So we can add this method to our toolbox, and we'll be creating a beautiful pink toolbox while we're at it. The other thing that we can do is we can detect drag gestures. So during a drag, this onDrag lambda will be called, and it will be called continuously. So every single drag that you're doing while you're dragging your finger over the screen, that onDrag lambda will be called continuously. Now you can limit your drag detector to only respond to vertical dragging or only to horizontal dragging. And you can also decide to only detect drags after the user has done a long press. And then you can also detect multi-touch transformation gestures, such as panning, pinching, and rotating, by using detect transform gestures. This makes a full list of all the gesture recognizers available in the pointer input scope. So it is a list, but it's not an extremely long list, right? And if your gesture that you want to recognize does not fit any of these, then you would actually have to fall back to that kind of low-level event handling. So with this list, we can now continue to the gesture modifiers. The gesture modifiers can be applied directly to a composable, so you don't need a pointer input modifier instead. Besides this more concise way of writing, there's some handy extra functionality, and we'll look into that a little bit later. So first, the clickable modifier adds click behavior. This is similar to the detect tap gestures recognizer that we handled before, but it only responds to single taps. Again, you pass a lambda that is called when the composable is clicked. If you want to react not just to single taps, but you also want to respond to long presses or double taps, you can use the combined clickable modifier instead. Again, you just have to implement those callbacks that you're interested in, right? And you can use the draggable modifier to listen to horizontal or vertical drag gestures. In this case, instead of passing a single onDrag lambda, you pass a state. And this is actually a common pattern, like passing in a state, and that makes it possible for you to kind of hoist that state. So you can move the actual state out of your modifier and then pass it into it. And that way you can also access it outside of the modifier, or you can change it from outside of the modifier, and so you can kind of make things dependent on one another. The scrollable modifier works the same way, but it includes logic for scrolling and flinging when you're using it. And the transformable modifier makes it possible to listen to multi-touch transform events on a composable. Okay, that's the toolbox. Quite a nice toolbox to play around with, right? It's a set of custom gesture recognizers and a set of modifiers that we can use directly. So now how do we choose between them? For example, we see both this clickable and detect tap gestures, and both of them are recognizing taps. So as I said before, like the modifier actually is doing more than that. And to figure out what exactly it's doing more, let's look at its source code. So if you look at the implementation of the clickable modifier, you can see that it not only adds gesture recognition, but it also adds accessibility support. It adds click semantics to deal with accessibility. It adds key detection, and it adds focus support. And it even adds like some beautiful, I think it's called a indication, which gives you this ripple support. So there's a lot of stuff going on there. And so this tells us that we should be considering that as well. Like if we drop down to just a gesture recognizer, that means that at that point we should be implementing these things ourselves, right? So this is quite a common pattern. When you use the various detect methods that are shown here on the left, you're purely recognizing gestures. If you use a high-level modifier, such as clickable or draggable, they include support for other types of input as well. So in general, you kind of want to use those modifiers because they give you all those extra functionality, and so everything works on every kind of device. And you should only drop down to the recognizers if there is a good reason to, and then consider how you should handle other devices yourself. We'll see some of those reasons later in the talk, though, so I'm not just going to go with the modifiers. Now there's one other thing to keep in mind when we're talking about this, and these modifiers exist only to recognize gestures, and they don't actually transform anything, so they just recognize the gesture itself. So if we look at the transformable modifier, for example, we see that it gets this continuous updates of zoom, offset, and rotation changes, right? Now let's say that we want to use that modifier to create an element that we can move around with 2 fingers. That seems like a logical thing that we want to do. Then just applying this modifier is not enough. This is just recognizing that gesture, not actually changing that box. So we need to apply the modifier to the box composable. And this is where we recognize the gesture, But then if we want to do something with those values, we actually need to hold the current scale, rotation, and offset values. In this case, we keep track of the current scale, current rotation angle, and the current offset. Now, we also need to pass logical initial values for those, of course. And then from our gesture recognizer, we can update these values whenever the gesture receives new change. And finally, we apply the transformation values to our composable. In this case, I'm using a graphics layer modifier to set this composable's scale, translation, and rotation. So to repeat, what we're doing is we recognize, we hold, and then we apply the data that's coming in through a gesture. Decoupling the recognition from the application also means that a gesture recognizer does not need to be applied to the same composable that you're actually transforming. Instead, you can move the modifiers around. And now you can recognize a gesture in a parent, but then apply it to a child composable. So in this case, the user can perform a gesture on the parent box, but then, if you look at it, the actual transformation happens only on the inner box. So this gives you kind of the opportunity to have a gesture on your whole screen, for example, but then apply the result only on a part of your screen. A real-world example of this is the material slider. So the gesture recognizer is defined on the full slider component, but the transformation only happens on the thumb handler that you're seeing. So this way I don't actually, as a user, have to grab the thumb handler, but I can start that drag from anywhere. And you might have seen that at some point that some websites or some apps actually don't do this, and it's really annoying to find that right spot to start dragging. Okay, that was a lot of theory, I know. We have a basic understanding of what we're doing. So let's actually go and create some actual gesture recognizers. Let's go. What we're going to be doing is we're going to be creating this photo grid sample app. And there's a lot happening here, and we'll take it step by step. And before you ask, the code is available in the gist. You can go to Google/compose photo grid, and you'll be able to read through it and kind of on your own terms understand it. But we'll be going through most of the code here as well. So what requirements do we have to implement? First, what we want to do is we want to be able to tap a photo so that we can open it full screen. Then we can double tap that photo to zoom in or to zoom back out. Alternatively, we can also pinch to zoom. So it should work on double tap, but it should also work when we pinch. And then while we're zoomed in, we want to be able to drag around to move around the photo. And also we can tap the gray background outside of the photo to exit our full screen mode. So let's go and implement these one by one. Like if you see them all at once, it can seem a little bit daunting, but if we break them down into these separate steps, it's actually quite doable. So for the first requirement, we want to tap the image to open it full screen. Quite a common scenario, right? We can choose between the detect tap gestures recognizer or the clickable modifier. Both will do the trick, but as we discussed before, the clickable modifier will actually add some extra functionality. So let's go with that. And let's go and implement our code. So we're going to start from the basics. We implement our photo grids. We create a composable and we pass it a list of photos. We create a lazy vertical grid with cell sizes of at least 128 dp. And inside, we add all the photos as separate items, with their ID as the unique key for that item. Each item is then represented with its own photo item composable, and we'll implement that one later. So with this, we actually already get some gesture handling in our app. So lazy vertical grid comes with scroll support right out of the box. So by just implementing a lazy vertical grid, you can use your fingers to scroll through that grid. And this is an example of kind of that highest abstraction level that I was talking about before, a composable that already includes support for gestures. Now let's implement our first requirement. Clicking one of the photos should open it in full screen mode. We first wrap our photo grid in a top level app composable, and then we add some state. We keep track of the photo ID that should currently be showing full screen. So when you start the app, this should be null because no photo has been selected yet. If this active ID is not null, that is, a photo has been clicked, we show the full screen photo. We look up the photo that belongs to this identifier and we pass it to the full screen photo composable that will be responsible for showing that full screen photo. Finally, we add the callbacks to update the active ID. So we pass a navigate to photo lambda to the photo grid composable and an onDismiss lambda to the full screen photo composable. Going back to our photo grid composable, this now gets that navigate to photo lambda. We add a clickable modifier to the photo item, and we call the navigate lambda when the user clicks this element. And with that, we finished our first requirement. Okay, told you we were going to start basic, but we'll be building this up, right? So next, while showing the full screen photo, a double tap should zoom in or out. So how would that work exactly? Well, when the user double taps, we remember the tap location on the screen. We then scale the image around that point, while making sure that it stays within the bounds. So a couple of steps here. So to implement that requirement, we again have two options. We can use detect tap gestures and combined clickable. Let's implement our code and see which one actually fits. For that, we first need to learn more about the full screen photo composable. It gets a photo, it gets the onDismiss lambda that should be called to exit full screen mode, and it gets an optional modifier that's a best practice in Compose. Inside, we define a box that fills the whole parent and centers its contents. In the box, we'll have a scrim and we'll have the image. The scrim will basically be a semi-transparent background that we can click to exit full screen mode. And we'll get to that later. Right now, the photo image composable is the one that we're interested in. So we want to zoom its content, right? So let's look at the photo image. It contains an image that we initialize with the URL of the photo. Then we pass it the photo's content description, and we set its aspect ratio to make sure that it is actually square. Let's add some variables to hold our state. We'll keep track of the offset and the zoom level. The offset is used so that we can zoom in on this specific part of the image, so that when you double tap in the right hand corner, it actually zooms in on the right hand part of the image. Now we can use a graphics layer modifier to apply these values to the image. And we use the offset and zoom values to translate and scale the composable. And we set the transform origin to make some of our calculations easier. And then we can add a clip modifier to make sure that the image stays within its bounds even when we scale it up or when we move it around. Now we're ready to add our actual gesture recognizer. We might be tempted to use the combined clickable modifier, but the on double click does not contain any information about the location on the screen where that double click happened. So we can't really use it to update our offset value, right? So this is why we would have to revert to our detect tap gestures recognizer. This one passes the tap offset as a parameter to the on double tap lambda. And we use that tap offset to calculate our new zoom and offset values. Now I'll leave that actual calculation out for now because it's like a little bit difficult to wrap your head around, but you can always go to the gist and read up on it later. It is just a one-liner doing some calculations, but you have to understand like X, Y stuff going on. Okay, so that's the double tap to zoom. Works out of the box. Now, you do remember that I said that this leaves out some functionality, and we'll get to that later, so don't worry about it. Now let's cover the pinch to zoom and the drag to pan. For these requirements, we should recognize all sorts of movements. So we want to listen to two pointers for zooming and a single pointer for panning. And that's where we again have two options. We can use detect transform gestures, or we can use the transformable modifier. Okay, so we want to see what behavior we want. When the user pinches to zoom, we want the image to zoom around the middle of that pinch gesture. So this is what we represent with that orange dot, and we call that the centroid. The transformable modifier does not get that centroid, and the detect transform gestures method does. So we know which one to use, right? We need to use the detect one. So going back to our code, our hold and apply blocks can still be the same because we're still dealing with offset and zoom values and apply them to our composable. We just have to add another gesture recognizer. So we add another pointer input modifier, this time detecting transformation gestures. And this will continuously call the lambda with delta values for movement and scaling. So we continuously get new values, right? We calculate the new offset value and the new zoom value. Again, I'm leaving out the calculation because it's hard to wrap your head around, but it's just a couple of lines of code. And with that, we can actually zoom and we can actually pan. Quite cool. Now, the only thing we need to allow the user to do is to click in the scrim to go back to kind of the photo grid itself. So going back to our full screen photo, remember that scrim composable that we were dealing with. If we look at its definition, we can see that it's currently just a simple full screen box with a grayish color, nothing special. And we can add behavior to it by passing an onClose lambda and calling that lambda when the user presses the box. In the full screen photo, we can simply forward the existing onDismiss parameter to this scrim composable. And with that, we have it all done. So as long as we go into a full screen image, we can zoom, we can pan, we can do a lot of stuff, and that all works. But I actually want to talk about one more thing, because although this is amazing and your users will be extremely happy, at some point you will have users that have some accessibility needs. So I do want to talk about accessibility a little bit, and specifically TalkBack as an accessibility service. It's used by people with visual impairments, and they can use it to kind of easily go over the screen and focus on the right elements and basically use an app the way that people with complete eyesight can do. And when TalkBack is enabled, it actually captures all of the gestures that a user makes. So that whole gesture thing that we were doing doesn't work, right? So none of your custom gestures will be available to the user. Instead, TalkBack will be handling all gestures. So for example, a swipe to right will focus the next element, a double tap behaves like a click, and a two-finger swipe creates scroll events. So all of that works differently from what you've been implementing, right? And any gesture recognizers that you applied to your composables won't work out of the box. So you'll have to configure your composable to explain to TalkBack what it is you're trying to accomplish with your gesture recognizer. And in our requirements, that means that the clickable that we had actually handles accessibility for us because it's a top-level modifier. However, the double tap to zoom, the pinch and drag to zoom and pan, and the tap to cancel full screen won't work out of the box. So there's a whole talk that I could do about accessibility in Compose, have done so at some point, but this is not that talk. So there is a beautiful documentation page on it. If you go to Google Compose accessibility, that's where you can find it. And it will explain in much detail how you can kind of go about this. I also am very passionate about this. So if you have questions about gestures and accessibility, please come find me. So that was a lot. Let's do a quick little recap of what we've been doing. We have a toolbox. It has gesture modifiers. It has gesture recognizers. And the difference between them, we discussed, how the modifiers contain more behavior than just that gesture recognition. And so if you use a gesture recognizer, you have to think about these things yourself. Then we implemented everything in our beautiful photo grid application. And then we also thought about accessibility considerations. So for the last bit of this talk, I want to talk about what we learned and then apply it to the photo grid composable. So our goal is to be able to select multiple photos in this grid. A user should be able to long press and drag to select multiple photos at once. I actually kind of looked at Google Photos, who's doing this, and I was like, how are they doing it? Well, they weren't using Compose, so I'm trying to implement this in Compose now, right? And it's actually quite doable. It's really cool. So let's break it up into these separate requirements again, so we know which steps we have to implement. So first, the long press should start this selection mode. So when you long press a photo, it selects that photo, and now we're in a selection mode, and we can start adding other photos to the selection. Tapping any photo should add them to or remove them from the selection. And then when the user long presses a photo and starts dragging, the photos in between should be selected or deselected. And then finally, when the user removes the last photo from the selection, we should exit this selection mode again and go back to our normal grid. Now, before we implement this gesture, I'd like to pause for a second and think about state management. That is, what state should we be keeping track of in our composables to correctly render our grid? At any given time, we're going to be having a set of photos, a set of photo IDs that are selected. So when there's no photo selected, like here on the left, the set is going to be empty. And on the right, you can see an example with 4, 5, 6, and 8 being selected. We also want to keep track of whether or not we're in selection mode. So that's basically going to reflect in our UI, right? So at least one photo when at least one photo is selected, we're in selection mode, otherwise we're not. So when selection mode is true, the left top corner of our photo should be showing this radio button, and then we should also handle our gestures differently. So let's keep track of that information in our photo grid composable. Now remember that the photo grid composable currently is just simply showing a lazy vertical grid with the photo items in it. We can add this variable selected IDs that can keep track of all the photos. Now, of course, you would normally move this into a view model and you would have brilliant architecture behind it. For the sake of this talk, I have all the state in our composables themselves. We use remember savable so that this variable is persisted across screen rotations and orientation changes, configuration changes. It's a pattern that you might want to consider to make sure that your state is constant. Now, in addition, we want a simple Boolean to tell us whether or not we're currently in selected mode. Now, this Boolean will only change when we move from an empty list to a list with at least one photo or the other way around. So we want to use derived state of. This makes it sure that our composables that rely on the value of the in selection mode variable will only recompose when it actually changes from true to false and the other way around, and not all the time. Now, in addition, for each photo in the grid, we can look up whether that specific photo is selected by checking if it's part of the set of selected IDs. Now, again, we're using derived state of to make sure that we only recompose depending on this state when it actually changes from true to false and the other way around. And we then forward these properties to the photo item composable, and it can adapt its UI based on their values. And inside the photo item composable, we use these values to choose what icon to show, if any. When in selection mode is true and the photo is selected, a check mark is added. If it's true but selection is false, then an unselected radio button is shown. And if we're not even in the selection mode at all, we're not showing any radio button or anything. So with that, we have state management, which is awesome, and we reflect that in our UI. But we don't have any way to actually change our state yet, right? Like, it's just given our state, we can render it beautifully, but we now need to actually change the state, which is why we're adding gesture handling. Now remember, we want a long press on an item to start the selection mode and directly add that photo to the set of selected photos. But we also already had a normal click listener defined in our photo item to open it full screen. So now we want to do two things at once. We want to respond to a normal click, and we want to respond to a long click. So let's go to our toolbox and see which handlers would fit that requirement. We can choose either detect tap gestures or combined clickable. Now remember that detect tap gestures only gives us the raw gesture handling, and combined clickable actually includes extras such as accessibility and focus support. Now this sounds great for our use case, so let's use combined clickable in this case. We go back to our photo grid composable, and we already had that clickable modifier from before, so we want to change that one to combined clickable. And for the on-click lambda, we pass the same behavior as we had before, but when the user long presses, we add the ID of the photo to the set of selected IDs. And by simply changing that mutable selected ID state, any composables that depend on that state will automatically recompose and update their UI accordingly. So we have our first requirement, and we can long press, and we used combined clickable. However, right now, if we click a photo while we're in selection mode, it opens it full screen, because that functionality was already there, right? But we don't want that. We want it to add it to the selection. So how are we going to do that? We want to create this kind of behavior, right? Clicking, adds, and removes. So let's go back to our photo grid composable and adapt this gesture behavior. We want this behavior to be different depending on our in selection mode state, right? So we can add an if-else statement and apply a different gesture handler based on the value of in selection mode. It's quite cool that, like, in Compose code, you can just add these kind of if-else statements or whatever and just like do different things depending on your state. So in this case, if in selection mode is true, we want to listen to taps and add or remove the photo from our selection. So we add a clickable modifier, and we let it remove the photo ID, or we add it to the set when it's currently unselected. And with that, we have a second requirement solved. We can enter selection mode, add or remove photos while in selection mode. Now we want to use long press and drag to select multiple images at the same time. That's the most difficult one, I guess, right? So let's see, which of the toolbox methods will fit. We need a handler that waits for a long press to happen and only then passes on any drag events. Now there is a detector that does exactly that. I kind of already said it. It's the detect drag gestures after long press. It's a fair mouthful. And it will help us to implement this multi-select mode. This is my favorite recognizer, by the way. It waits for a long press to happen, will forward all of the drag events to a lambda. And it also contains these kind of lambdas for when the drag starts, when it's cancelled, or when it ends, so you can correctly handle these kind of terminal events. For our multi-select case, when the drag starts, we should add the photo underneath our pointer to the selection. Then when we drag, when the pointer moves to a new photo, all photos in between the old and the new photo should be added or removed from the selection. Okay, so which composable do we apply this gesture handler to? Do we apply it to the single photo item, or do we apply it to the whole grid? Well, in order to understand what we need to do, we have to understand a little bit more about hit testing. So let's take our app and look at it from an angle. So the UI of our app consists of these layers, where our photo items are at the top, grid is in the middle, and the main app container is at the bottom of the stack. When we touch our screen, a hit detection algorithm runs. And you can envision this as a ray being shot at your hierarchy. In this case, that ray will first hit one of the photo items. Then it will hit the grid, and then finally it will hit that app container. Now, as the user drags their finger over the screen, this imaginary ray that's shooting at the screen changes position. But it's important to understand that it doesn't perform any more hit testing at that point. So even though it exits the bound of the middle photo, that photo composable would still be the one that receives those drag events. So as long as that gesture is in progress, only the composables that originally registered and originally got hit will actually get those updates. This is a performance consideration, but it's important to know about it. And for us, it's important to know because our requirement includes adding and removing photos as we drag over them. So imagine that we would register the drag listener only on a single photo item. Then, when the pointer exits its bounds, it doesn't know which photo it moved to. And so in this case, we need to listen to the gestures on the whole grid, so that given a location of the pointer with the grid, we can calculate which photo it is pointing at. And then we can, when it moves out of the bounds, we can recalculate and we can figure out which photo it now points at. So let's go back to our photo grid composable with its lazy vertical grid. We add the pointer input modifier and we use our new detection methods. So let's, update our selected set. It's basically, we kind of want to make sure that during our on-drag start, we want to figure out which photo was originally selected, keep track of it. And we also want to add this initial photo to the set of selected photos. And then when it's cancelled or it ends, we want to reset anything. And during on-drag, we want to figure out if the pointer changed from one to the next. To know which photos to add or remove, we need to both the identifier of the photo that was initially hit and the identifier of the photo that the pointer has last been over. In the on-drag start lambda, we get an offset that indicates where in the bounds of our lazy grid the pointer went down. And we can use that offset to find out what photo the user is pointing at using a helper method. And you can find the implementation of this in the gist. Again, I know that this is like the meaty part of the things, but trust me, it's hard to explain in 40 minutes. In the end, it does work. It's 3 lines of code, but there's a lot of XY parameters going on. If the photo was indeed hit, we check if it wasn't in the selection, and we can save it as the initial and current photo ID and add it to our selection. Now in on-drag cancel and on-drag end, we reset the initial photo ID to null. And in the on-drag lambda, we handle these actual drag events. So this lambda gets a change event as input, and in that change event, there's a position field that contains the offset in the composable where the event happened. And we can reuse that same photo ID at offset helper method to see which photo the user is pointing at. And now during the drag, we're continuously tracking which photo ID is underneath our pointer. Now we're only interested in the movement from one photo to the next, so we check if that ID is actually different from the current photo ID. And so we update the current photo ID when we're done with our update. And finally, we can update the set of selected IDs. This is part of our business logic, it depends on how your list works to kind of define which one it should be adding and removing. And with that, we can successfully long press to enter selection mode, tap to add or remove, and we can long press to, wait. It's not working. Why is that? Well, in order to figure that out, we need to talk about conflict resolution. Remember that we solved our initial requirements with a combined clickable modifier, letting it listen to long press events. But now we're also detecting drags after long press, so both the photo items themselves and the grid are actually listening and trying to react to long press events. So we have a conflict. And if we look at the layered version of our UI again, when a pointer event comes in, the layer that lies on the top gets the event first. In this case, that's our photo item. And it chooses whether or not to consume that event. And only if that layer does not consume the event, it actually forwards to the next layer. So it's good to keep in mind that what we're doing is if we consume an event, the rest of the UI will not know about it. So in our case, the long press recognizer we added to the photo item composable, it captures and consumes all the events. So our photo grid will never ever get any of those events, and its long press and drag recognizer will not work. Now looking at the code, the on long click in our combined clickable is the culprit. It blocks the long press and drag of the grid. But actually we don't really need this long click listener anymore. The long press and drag listener of the grid was already adding the photo to the selection after a long press. So we can just change this combined clickable next to the original clickable modifier. And now it works, cool. We can successfully long press, we can tap to add or remove, and we can drag to add or remove multiple photos. Now finally you want to be able to tap the last selected photo to exit selection mode. But actually this already works out of the box, because we made our selection mode dependent on the set of selected IDs. Deselecting the last photo automatically exits selection mode. So with that, we're done. Now we're also almost at time, so to close off, I have a couple of resources. This is the point where you can take pictures if you're interested. There's a blog post about this, where basically I'm just explaining the same thing with code snippets, etc. There is also a video, actually, with basically almost the same thing that I was telling here, but in a much smoother voice and in a studio, which I can definitely recommend if you want to look back at this and see if you missed anything or you want to share it with someone. That's kind of nice to find. And then we have the official Compose documentation, also has that video on it, so that's going to help. And it explains in much more detail like kind of how this all works. Then the source code of this photo grid example is at google/compose photo grid, or you can scan this QR code, which I always wonder if it actually works in practice. So if it doesn't, you have the picture, so you can always just go to that link. This is another example that I've been playing around with, which I showed at the beginning, which is basically, dragging over a graph and then showing some UI based on that. And then finally, we have google/compose chat, where I'm using the anchor draggable to implement a swipe to cancel. And with that, that's all I have for today. So thank you very much for coming on such short notice. Much appreciated.